So, welcome students. This will be the first lecture on distributed system. Basically, we will try to introduce what is distributed system and what are the applications of distributed system and how this distributed systems is facing the challenges. So, let us start with the distributed system. Basically, distributed system is a collection of autonomous computing elements. Computing elements means autonomous computers. So computing devices, I should say. So what actually we want is these computing devices are connected with networks. Connected with the networks. The users, it appears to the user like it is a single coherent system. So the user is unaware that there are multiple computers connected in a network and it is interacting. Some of the resources it is getting from node 1, some of the resources from node 2. It is unaware, the users are unaware. Actually, in the distributed system, maybe some resources are on one node, some resources are on another node, but these nodes are connected together. So, what happens, the users feel like they are interacting with one system. So we are calling such a system as a distributed system in which multiple computing devices are connected together and share resources. Means some resources are at some node and some resources are at another node. But to the users, these all the computers together appear as one single coherent system. So what happens actually here, autonomous computing elements are there, also referred as nodes. Hmm. They may be hardware devices or software processors, noises. Also, the users and applications perceive a single system. They believe that they are interacting with a single system. Okay. So same thing in this book of Douglas. What you will get is they are saying that there are networked computers. The network computers which communicate with each other and communicate and coordinate their actions only by passing the messages between them. These network computers, they pass messages between them, and then they are able to share resources, perform the required computing. Okay, so what are we saying is collection of autonomous nodes means independent behavior. Now what we are saying is since all the nodes, all the computing devices, they are autonomous, they have their own timing notion. So we don't have one centralized clock. In that case, some of the processes which are running, we sometimes we need that there should be a stepwise execution, step 1, step 2, step 3 and so on. In that case, now what happens, since the clock is not there and computing devices are distributed, now if we are trying to parallelize and some of the operations step 1, 2, 3, 4, and we are giving it to different devices, maybe step 1 and 2 they can be run parallelly, but step 3 can run only after 1 and 2 are complete. In that case, We need a proper synchronization, like when 1 and 2 are complete, then only the third should start. Until that time, the third should wait. So this is not possible without synchronization. Okay. The thing is, just by using clocks, it is not possible. And also, if we are giving just timing that this process runs for 10 seconds, another process for 10 seconds, and the third process, this is after 10 seconds, this should start. Exactly, it is not that case, since they don't have a global clock. So synchronization is something that we will need. Synchronization means we will put an explicit condition that once these two steps are complete, then only this step should execute. So the other thing is collection of nodes, means these independent nodes are uh, grouped together. So the thing is, we will try to understand how to manage this group membership. Who can be member, new members can be added or not, who will be the head of this group, kind of things are there. How to know that you are indeed communicating with an authorized member, means since you have made a group, so you will have to understand, you will have some method to find out the authenticity of the members. Now, organization. We are talking about the network, means how they will be organized. As we told that there are computing devices networked together. So how they will be networked? Maybe there will be something called peer-to-peer system. Is it possible? The systems are connected to each other. Others can be, see, different other options are also there. We will go through them. But for now, you can understand that it can be structured or unstructured, means well-defined set of neighbors, that this one node 1 is neighbor of 2 and 3 only, not 4. It is well defined that this is the way the network will remain. Unstructured network, it may also be possible that randomly, as per the requirement of time, dynamically they can structure themselves. Means maybe it happens sometimes some node crashed. In that case, what will happen? We will have to dynamically re-arrange our network. In that case, we will have to take care of a few things. We will go through it. So, what here we have to understand is the network can be structured or unstructured. Now, what do we mean with coherent system? Actually, the collection of nodes as a whole operates the same. uh, no matter where, when, and how interaction between a user and the system takes place. The user directly interacted through node 1, through node 2, or through node 3, or through any other node. It doesn't matter. It is interacting to one single system. Mhm. So, for an example, as we are saying, is an end user cannot tell where the computation is taking place. They are unaware where the required computation is taking place, node 1, node 2, or node 3. They don't know. Actually, where the data is stored, they don't know. The data has been replicated or not, they don't know. These are the things which the users need not be aware of whether the data is replicated or not, data where the data is actually stored on node 1 or node 2, where the computation is taking place. So these kind of things we are calling it as a distribution transparency. Okay. One thing that we come through is the snag, which we also call as partial failure. Means, as we have seen, that distributed system is a collection of computing devices. I should say network of computing devices. So some of the node may crash. We are calling it as failure of that particular node. So if we consider this distributed system where multiple nodes are there, one of the node is crashing. So we are calling it as partial failure. Okay. We also name it as snag. Okay. So let me tell you something about this system. Suppose we are having this thing, four computers, right, connected with some network, some kind of networking. Different kind of topology can be adopted, which is being adopted, no issues. Let us assume they are just connected using some topology. Now, what we are saying is it doesn't matter that these computers are using which hardware device, are having which operating system. The operating systems can be different. The what we call it, this hardware may be different. What we actually need to do is a middleware. We call it a middleware. It is distributed system layer. Means a software, a simple software that will help you manage these four computers. Okay, and this middleware will help you in presenting these four computers together as one single system to the users. So in that case, what will happen? Some of the application, like application A, application B, and application C, can run on any of the computers. To the user, it will be like they are interacting to one system, no issues. Now these applications can be totally on one system, like you can see application A is totally on this computer one. However, for application B, you can see it is on 2 and 3 both. Okay, so such of the things are also possible, and the users, when interacting with the system, they will not be aware where actually the resources are being stored, from where the application they are accessing, whether from computer 2 or computer 1 or computer 3 or 4. So now what happens is this is the middleware, commonly used components and functions that need not be independently implemented by applications separately. Okay, so each application need not implement these functions. One middleware is there which will take care of these all the things. Then what do we actually want to achieve with this distributed system? With this distributed system, we actually want to share the resources. There are resources that we want to share. Sometimes some resources which are there at one node, some resources are another node. and we don't want the users to bother and remember the address of each node for different resources. They can interact with one system for their resources. That will be easy for them. So, supporting the sharing of resources, this is one uh, application that we need. Uh, One thing that we want with the distributed system. Another is distribution transparency. Distribution transparency, as we have seen, what it was is we want users to unaware of uh, where the data is being stored, where the computation is taking place, where the application is not, are there, and some more things we will see in the next slide. We will also want to have this openness, whether it is the system is open to all the different kind of system or not. Hmm. Interfaces are okay or not. Scalability means whether new, I should say, if the requirement uh, improves, improves is not the correct word. If the requirement is more, we can add more resources. So a distributed system should be scalable, which means as the requirement increases, we will add more resources and we will be able to serve the users. So sharing of resources. So what it means is we want to share the resources. Now cloud-based shared storage and files, peer-to-peer assisted multimedia streaming, shared mail services, shared web hosting. So these are different examples for sharing of resources. Now, what we observe is the network is the computer. What they are saying is the network of computers. Means the computers are there, they are networked together, and now they are performing as one single computer. So it is saying that the network is the computer. You are interacting with a network actually. Some of the resources are at node 1 and node 2 and node 3, but you believe that you are interacting with a single computer. Okay, so now let me tell you about distribution transparency. In distribution transparency, as you have seen, that we want to hide some of the information from the user. One is access transparency. Here we want to hide differences in data representation and how an object is accessed. Okay? How it is accessed and how it is represented. We want to hide the detail of these things. Location transparency means we want to hide where actually the object is located. Relocation transparency means we want to hide that an object may be moved to another location while in use. Okay, the user is accessing something and the object may move from one to other place, but it may not be a problem in the user's computation. Migration transparency means object may move from one location to another. However, in a distributed system, user can always access it. Replication transparency means in replication transparency we hide the detail that an object is replicated or not. Concurrency. Concurrency transparency means we want to hide that an object may be shared by several independent users. Means the users may share some things, but they may not be aware that the thing that they are accessing, the resource they are accessing, it is being accessed by other users also. Failure transparency. We want the distributed system to hide the failure and to recover the objects. Okay. Then this is the degree of transparency. We are saying that if we want to have full distribution transparency, it is a difficult thing. Hmm. See, there are communication latencies that cannot be hidden. Uh, Failures are another thing. Hiding these failures is also a tough thing. Okay, so what is happening is you cannot distinguish a slow computer from a failing one. Uh, so all the research is going on and we are working on it. In future, we may get such other things where we can hide the failures. Now, what they're saying, we are not sure whether a server actually performed an operation before a crash. You know? Once it crashed, whether it performed something or not, we don't know. Hmm. So several such things are there. Now, if we want to achieve full transparency, there will be a cost associated to it, like keeping replicas. Uh, Now, keeping replicas will cost us. Immediately flushing write operations to disk. Whenever write operation is there, if we want to write it at the same time before the system crashes. So each time we are keep writing, it will be time consuming, I should say costly. So now if we want to expose the distribution, it may also be sometimes good. Like if you want to use location based services, finding your nearby friends, mm, you can uh, show the location. It will be easy. It will be cost effective in this case. When dealing with users in different time zones, when it makes it easier for a user to understand what's going on when a server does not respond to a long time or report it as failing. So these are sort of things which may happen. So this, as we have seen that there this kind of degree of transparency. So achieving this distribution transparency is a goal, I should say, which is really a nice thing to achieve. But achieving this is difficult. This is the thing. We have seen different kind of transparency, and I'm telling you that achieving this transparency is difficult, and research is going on nowadays for different for achieving this transparency. I will tell you about openness, where we just want it to be able to interact with services from other open systems, irrespective of the underlying environment. Systems should conform to well-defined interfaces. There should be well-defined interfaces. Now, systems should easily interoperate. Uh, Systems should support portability of the application. Application should be. portable from one system to another. Systems should be easily extensible. Policies versus mechanism. Actually, for these, what we call is openness, there should be particular policies. So these policies will tell you what level of consistency do we require for client cache data, which operations do we allow download code to perform, which QoS requirements do we adjust, means quality of service requirements do we adjust, what level of security do we require. So here just we are defining what do we require and what should be there, what should be there. Now there is mechanism, means here we actually define the particular setting that we want. So we are allowing the setting of caching policy. So what kind of caching policy do we want? It may be dynamic or something fixed. So here we are supporting different level of trust, mm, of mobile code, for mobile code or something, maybe for other also, for mobile code if we are telling you, providing adjustable QoS parameters. We are just telling you these are the parameters which can also be adjusted. We can offer different kind of encryption algorithms for the secrecy, the level of security we have defined in the policy. So actually we want to have a concrete distinction between policy and mechanism. So this is we are telling you about there should be a strict separation between policy and mechanism. Now if more stricter this separation is, the more we need to make ensure, I should say, proper mechanism, potentially leading to many different parameters and complex managements. So more stricter separation is more difficult to implement, but still it is better. So if we want to have a balance, hard coding policies often simplifies management and reduces complexity at the price of less flexibility. So there is no obvious solution. We will have to understand and then take necessary steps. If we talk about the scale of distributed system, let us talk about this scale in the next lecture. Okay. For now, today you have seen something about the distributed system. In distributed system, you have also seen that it is just network computers, and to the users, it appears as one single computer. So, what we want actually is we want to share the resources. There is distribution transparency, different kind of transparency we have seen, openness that we want to achieve, and the scalability that we want to achieve. We will see the scalability in the next lecture. Thank you.